Hello, my dears. I'm at home today because I'm not feeling well, as I'm sure you can hear. Wanted to create a video for you to help guide you. What I'm going to do is kind of give you a general overview, and then I will do an example where you can just watch and learn. I'll do an example where you can pause it along the way and try it with me. And then finally, I'll do an example where you try it all the way through, and then you can watch the video to see if you did that correctly. So I wanted to introduce the product rule to you today. And the product rule is what we use when we have a function, so y equals two functions being multiplied together. Now, one of the hardest parts of this is being able to identify when you use what, because some people will struggle with, am I using the chain rule or am I using the product rule? So what you're going to want to think about when you're doing these problems is whether or not it's a chain rule or a product rule. So remember, a chain rule is a function that has one function nested inside of another. So it's really just one function with multiple levels. And that's when we use the chain rule, which is when we take the derivative of the outside, leave the inside the same, and then multiply by the derivative of the inside. Now, the product rule, this is new today, is what we use when we have actually two separate functions being multiplied instead of levels. And what the product rule is in terms of f of x and g of x, and I'll show you a different notation on our first example, is if you start with y equals f of x times g of x, then the derivative is the second function times the derivative of the first plus the first times the derivative of the second. Okay, so let's look at an example of that in action. So this example, I'm just going to work all the way through, talking it through as I go. You're welcome to pause it if you like to, but this is just one where I want you to try and absorb it and work through it with me. So notice that this is a product rule problem, and I know that because I can see two very distinct quantities that both contain x. So it's two functions being multiplied together. Now, the first thing we want to identify is what those two functions are. All right, so usually we use u and v. So I call the first function u and the second function v. And that's just goes back to whoever came up with this a long time ago. I don't know why they chose u and v. You can choose any letters you want. Okay. So once I identify my two functions, what I do is I write them both down. So I've got u is x squared, and I've got v is x cubed plus 3 to the fourth power. From there, what I do is I take the derivative of each of those functions separately. So the derivative of u prime, I get to use the power rule. So I bring the power down, I go to one less power. The derivative of x squared is 2x. That one is nice and quick and easy. Now notice with v, I need to take the derivative of that as well. But this one is a chain rule. So what you're going to notice is that we're going to be using the chain rule inside of the product rule problems very frequently. So I take the derivative of each level. Derivative of my inside is 3x squared using the power rule. The derivative of my outside would be 4 times that same quantity to the third power. Inside stays the same. So to get my final derivative, I multiply these two quantities together to get 12x squared times x cubed plus 3 to the third power. All right, so here's what I've done so far. I've determined what the two separate functions are. I've labeled the two separate functions. And then I've taken the derivative of those two functions using whatever derivative rules I need to do. So here's what we do from there. All right, a lot of people think that we should be able to take the derivative by just taking the derivative of each one and then multiplying them together. But that won't work. That won't give us the final derivative. So that's where the product rule comes in. And what the product rule says is that if you have this product, you can find the derivative by taking the second function times the derivative of the first plus the first function times the derivative of the second. So that's why we identified the two separate functions, and that's why we took the derivatives of both. So from there, what I need to do is just multiply those. So v times u prime, let me take a different color here. So here's my v, and here's my u prime. If I multiply those together, I'm going to put the 2x out front, even though that's not v. I know you see this right here. It's in the order v times u prime. But I'm just going to use my math logic, and since this is a coefficient, I'm going to put that one first. And then I've got x cubed plus 3 to the 4th power. So I'm multiplying them together. I'm not going to do anything else because this is being raised to a power, so I can't distribute in. So I'm just going to leave it. All right, so what I have right here is v times u prime, or this order, I did u prime times v. Same thing because multiplication is commutative. Now I add my second product, so u times v prime. All right, so here's my u, here's my v prime. I'm going to multiply those together. And again, I'm just going to be smart about it, combining things where I can. So when I have 12x squared and another x squared, those are both coefficients. So I'm going to multiply them together to get 12x to the 4th, because x squared times x squared would be x multiplied by itself 4 times. And then the x cubed plus 3 cubed will just go second. So this is u times v prime. And that is my final answer for now. Tomorrow we're going to work on factoring to simplify, but for today I just want you to leave it in this form where you have the two separate quantities, the two separate products that are connected through addition. So that's your example. What I would recommend is if that was really seemed a little tricky to you, maybe watch it again. All right, on this next one, I'm going to tell you places to pause so you can try it on a sheet of paper or a whiteboard and kind of do that with me. So here's my second example. Notice that I am being asked to derive, which means take the derivative of y equals 5x squared times the quantity x squared plus 1 to the 4th power. So my first step is to identify what the two different functions are. So right now, I would like you to pause the video and label what u equals and v equals. So do that now and press play once you have it done. So hopefully what you identified is that 5x squared is u. So u equals 5x squared. V equals the quantity x squared plus 1 to the 4th power. Right? Now our next step is to take the derivative of each of those functions separately. So go ahead and pause the video and do that. Press play once you have it done to check. All right, so for u, we've got a basic power rule, so we bring the power down. 5 times 2 is 10. We go to one less power, which would be x to the 1st. For v, we have a chain rule. So our outside would be to the 4th power. Our inside would be x cubed or x squared plus 1. I take my derivatives, I put the original back inside, and I get my final v prime by multiplying these two functions together, which gives me 8x times the quantity x squared plus 1 cubed. So now what we need to do is put them back together using the product rule, which is VU prime plus UV prime. All right, so go ahead and pause the video and do that now. All right, so hopefully when all is said and done, this is what you got. So VU prime would get me 10x times the quantity x squared plus 1 to the fourth. Again, I put the 10x out front because that's the coefficient. I'm leaving the binomial second. Plus UV prime. So I'm multiplying the 8x and the 5x squared, which is going to give me 40x cubed. Then I've got x squared plus 1 to the third power. And for now, that's your final answer. Okay. Again, tomorrow we'll work on factoring to simplify. I think what I'll do at the end of this video, in case you're just chomping at the bit to do a little bit extra, I'll show you how to factor, but that is not an expectation until tomorrow. All right, let's do one more, and then we'll let you do a little extra practice. All right, so on this problem, what I would like you to do is try it the entire way through, and then watch the video, looking for places where you did things really well, looking for any mistakes that you may have made and learning from those. If you get it right the first time, amazing. If you don't, that's okay. Learn from those mistakes and try it again. All right, so pause the video now, try the problem, then play it through once you have it completed. All right, so let's go ahead and label our two functions. All right, so I've got U and V. So U is 4x cubed, and V is the quantity 5x squared plus 2 to the fourth power. U is a power rule, so I bring the power down, go to one less power. V is a chain rule, so actually let me get that out of the way. I've got my outside and my inside. Both of those are power rules, so I get 10x for the derivative of the inside, 4 times the quantity 5x squared plus 2 to the third for my inside. So my final V prime is 40x times the quantity 5x squared plus 2 to the third. So now, remembering my product rule, I've got VU prime plus UV prime. Here, I'll have 12x squared times the quantity 5x squared plus 2 to the fourth, plus, when I multiply these two coefficients together, that's going to be 160x to the fourth, and then 5x squared plus 2 cubed. Now, if you got that, you should give yourself a big old pat on the back, because this is really getting to some heavier mathematics, and you guys are rocking it. So if you feel like this is enough for you today, then I want you to just stop the video now, and then move on to the next part of the lesson. Okay? If you want to have a little preview of what we're going to do tomorrow, then go ahead and keep watching. And in case you're signing off, thank you for being awesome today. Thank you for being flexible. I appreciate you doing your best, and I will hopefully be there tomorrow to support you, right? Because I would rather be there than at home, sitting by myself. All right, so let's look at factoring. This is the part that usually is a little bit trickier for people. I'm going to make this a little smaller. All right, never mind. YouTube's cut me off because of video length, so I'm going to have to keep you in suspense. Thanks for being great today. We'll work on factoring tomorrow. I appreciate all of you.